Are you preparing for an interview or a job that requires SQL-related skills? Then you are at the right place, because based on different sources I have selected these top 16 SQL interview questions that you must prepare before going to any interview. And at the end, I have also included PDF notes that will help you to revise these questions whenever you want to. So let's get started. Question number 1. What is the difference between DBMS and RDBMS? So a DBMS stands for Database Management System, while RDBMS stands for Relational Database Management System. Further, a DBMS is a software package that allows users to store, retrieve, and manipulate the data in a database. Now these data can be stored in various formats, be it dictionaries, tables, or different structures. On the other hand, RDBMS is an advanced version of a DBMS, but still a subset of DBMS, which is used to store and manage the data which is stored only in the form of tables and no other structures. Question number 2. What is the difference between SQL and MySQL? So SQL is the structured query language, which is the language that we use to manage the data in an RDBMS system, where data is stored in a structured or tabular form only. Whereas MySQL is the RDBMS software itself, which is owned by Oracle Corporation. Now this question is often asked because SQL and MySQL often look very similar names, but they are completely different things. So SQL is the language and MySQL is the software in which this language is used. Now to make it clear, there are also other examples of these RDBMS systems like Microsoft SQL Server, PostgreSQL, SQLite, and MariaDB. Okay, next question. Explain normalization in SQL. So a normalization is a process of structuring a relational database in accordance with some normal forms or guidelines that we must follow. Now we use normalization in order to reduce the data redundancy and make sure that the data which is stored is well organized and accurate in the database. So a follow-up question that can be asked is, what are these normal forms and what are their types? So a normal form is nothing but a series of guidelines or rules that we must follow while normalizing our data in SQL. Now there are different types of normal forms. Most common of them are first normal form, which is often called 1NF, then we have second normal form, third normal form, and Boyce-Codd normal form. Now this Boyce-Codd normal form is also called the fourth normal form. Now we also have other normal forms like fifth normal form and sixth normal form, but they are not generally used. So these are the most common types of normal forms that we use. Further, the important thing to remember about these normal forms is that each of the normal forms are built on top of each other. By that I mean, whenever we have a second normal form guideline that we must follow, there is a condition that we must follow a first normal form, only then the conditions of second normal form to be applied, and so on for third and fourth normal form. In other words, we can say the strictness of these conditions increases when we go from first normal form to Boyce-Codd normal form. Now if you want to learn more about the conditions that are used in these normal forms, you can click on this video and learn them. Okay, coming to our next question, which is the fifth question. What are primary and foreign keys in SQL? So in order to understand this question, let us consider these two tables. So the upper table contains the information about the student name and roll number along with the total marks that he or she has obtained in final exams, while the lower table contains the information about the subjects that each student took in their final exams. If you observe, both the upper and lower table contains a common column, which is the roll number. So this column can be used to link these two tables and form a relation between them, and that's why this database is also called Relational Database Management System. Now the relation that will be formed between these two tables is also called parent-child relation. That means a hierarchy will be formed where the upper table will be the parent table and the lower table will be called the child table. Now once we have this knowledge, let us look at the definitions of primary and foreign keys. So a primary key is a column or a set of columns in a table that is used as a unique identifier for each row. Now if you consider the upper table, which is the parent table, the column roll number would be unique for each of the rows because every student in the class will have a unique roll number assigned to each one of them. Now whenever we say a primary key constraint, there are two constraints which are automatically imposed on that particular column, which are a unique constraint, that means all the values in the column must be unique. Then a not null constraint, which means that there should not be any null values in that particular column. A foreign key is also a column or a set of columns that is linked to the primary key in the parent table. Now if you see the lower table, the column roll number is the foreign key, and it is not necessary to have unique values in that particular column because one student can have more than one subjects, and hence why there could be a repetition of roll numbers in more than one rows. So a foreign key should not contain any unique values. But the foreign key should have a constraint that it should only contain the values that are referenced in the primary key or the values that exist in the primary key. That is, it should not contain any roll number which is not present in the parent table. Okay, so the next question is, what are the different types of constraints that we have in SQL? So we have different types of constraints, but I have listed some of the most common types of constraints that we use. Starting with a unique constraint. A unique constraint ensures that all the values in the columns are unique and hence are non-repetitive in nature. Then we have not null constraint, which ensures that the values in the column should not be empty or a null value. Then we have a primary key constraint, which is nothing but the combination of unique and a not null constraint, which we have already discussed in the previous question. Then foreign key constraint ensures that the column should only contain the values that exist in the primary key. Then we have the check constraint, which ensures that the values which we enter in that particular column should first satisfy this check condition that we have, and if only it satisfies it, then it will be allowed to store in that column. If not, it will give you an error. Then we have a default constraint, which automatically sets a default value for that particular column when you don't specify any value for any particular row. Then at the end we have this create index constraint, which is used to create the index for any particular table so that we can retrieve the data from the database very quickly in the future whenever we want. So these are some of the most common constraints in SQL that you need to know in order to answer this interview question. So the next question is one of the frequently asked interview question, which is, what are the different types of SQL commands that we have? Now we have variety of SQL commands, but they are generally grouped into different categories. These categories are DDL commands, DML commands, TCL commands, DQL commands, and DCL commands. Now I know that could be a lot of confusion, but let us see what each of these commands stand for, and then it will become a bit clearer. So DDL stands for a data definition language, DML stands for data manipulation language, TCL stands for transaction control language, DQL stands for data query language, and DCL stands for data control language commands. Now let us see some of the examples of these SQL commands that fall into each of these categories in order to understand it more better. So for data definition language, we have create, drop, truncate, and alter commands, which are actually used to create or change the structure of a particular table. Then we have insert, update, and delete in the data manipulation language, which are the commands that are actually used to manipulate the data in that particular table without changing the structure of the table. Then we have commit, rollback, and save point commands, which fall under the category of transaction control language commands. Now these commands are used to handle the database transactions, which help us to keep track of the modifications that we make using these DML statements. Then we have the most frequently used command in SQL, which is the select command, which helps us to read the data from the table and hence is also called a data query command. At the end we have a grant and revoke commands that fall under the category of data control language, which are the commands used to control the access to the data stored in a database. Using these commands we can grant and revoke the permissions to the users to access, modify, and work on a particular database. Coming to the next question, which is the question number 8, and this is also one of the frequently asked question, which is what is the difference between a delete, drop and truncate command in SQL? Now if we see the broader difference, the delete and truncate commands are used to remove the data from the table, while the drop command is used to remove the table itself. But if we go into further detail, the delete command is used to remove specific rows that we want to delete based on the conditions used under the where clause, and it's logged as individual row deletions, which allow us to roll back the command within a database transaction. That means we can revert the process of deletion. Then we have truncate command, which is also used to remove the rows, but it removes all of the rows from a table in a single operation without logging individual row deletion. That means we cannot roll back our transaction, and hence if the row is deleted, it's gone and you can't revert it back. Then we have a drop command, which is used to remove the entire database objects including the table or any given structure, and hence it cannot be rolled back as well. Okay, coming to the next question which an interviewer can ask you is what is alias and what is the keyword that we use for aliasing in SQL? Now this is pretty easier to answer. So in SQL we have alias, which gives a temporary name to a particular table or column in a particular query. Now aliases are used to make these queries more readable, concise, or to simplify the complex queries involving multiple tables or calculations. The keyword used for aliasing is as or as keyword. Now in order to understand how these commands are actually used, let us consider this example below. In this example we have selected employee ID and employee name as the column from the employees table, but we have aliased these columns with the temporary name of ID and name. Now the user will see only two columns in the output section, which is the ID column and the name column. But remember, these column names are just the temporary names that are being provided by the aliasing, and hence the name of the columns are still the same in the original table. That means aliasing can never change the column names in a particular table, and it can only show you the temporary name in a particular view. Now these temporary names, as we already discussed, can make things more readable, concise, or in some cases when you don't want to show the original name of the columns to maintain some privacy, this can also be helpful. I can understand that this could be a lot of information for some of you right now, and that is why I have compiled all the question and answers in a single PDF, for which the link to the PDF you can find in the description of the video down below. Okay, so the next question, which is the 10th question in our list, is what are different types of joins in SQL? So in SQL we have majorly 5 types of joins that we use. First one being inner join, then we have left join or left outer join, right join or right outer join, then we have full outer join, and at the end we have a cross join. Inner join returns the rows that have matching values in both the tables. By that I mean is it will join the tables and it will show you the rows which are present in both table 1 and table 2. Left join will return all the rows from the left table, which is the table 1, and the matched rows from the right table, which is the table 2. So by that I mean is it will join the table 1 and table 2, but it will return the rows which are present in the left table even if it is not present in the right table, and the rows which are present in both left and right table. Then the opposite of this could be the right join, which will return all the rows from the right table and the matched rows from the left table. And whenever it will return the values for the right table which are not present in the left table, it will replace them with a null value. Then full outer join returns all the rows when there is a match in either of the tables. So you can consider a full join as the union of left and right join. Okay, so at the end we have cross join, which returns the Cartesian product of the two tables. That means it will return all the rows with all the permutations and combinations that you can have between those two tables, which is table 1 and table 2. Now the next question in our list is what is self join in SQL? So self join is a type of join where a table is joined with itself. Now this is useful in the scenarios when we need to connect the information from one row in a table with the information from another row within the same table. Now let us understand this with a simple example. Suppose we have a table with the name employees. Now in this table we have the information about employee ID. In the second column we have employee name, and in the third column we have IDs of the manager of that particular employee. Now this manager ID is nothing but the employee ID of that particular manager. Now let us consider a scenario in which we want to find who is the manager of Charlie. Now if we can see, the Charlie has a manager ID of 3. That means the manager of Charlie has an employee ID of 3. And from the same table itself I can see in the third row that Bob has the same employee ID. So in that way I can conclude that Bob is the manager of Charlie. Now if you have observed, whatever information we need to fetch is contained within the same table itself, but in different rows. And that is what it means when we say that a self-join is useful when we need to connect information from one row in a table with the information from another row in the same table. To execute this task in SQL, we can write the following query. Now in this query, we have used the same table employees and considered two temporary names for the same table, which is E and M. Now the table E is considered to take the employee name, while the table M is considered to take the manager name of that particular employee. Now here if you see, we have used a join statement, which is nothing but an inner join that we can use on the table E and M on the condition where the manager ID from the E table matches with the employee ID from the M table. And when this matches, we can have that information about the manager names from the second table and the employee names from the first table, which gives us the final output as this. Okay, so here self-join was useful because the information that we need to find was contained in the same table but in the different rows. Moving on, the next question in our list is, what is a subquery in SQL? So a subquery is nothing but a query nested within another SQL query. Now this subquery is also known as nested query or inner query. You can see this particular example. Now here we have used select statement to query the student ID from the table grades. But we only want the information about the students who have scored greater than the average score in the whole class. Now in order to implement that, we have implemented a subquery in the condition where we have used a where clause. Here, before checking the condition, the inner query is executed where the average score of the whole class is calculated first, and only after that the score is compared with that average score, and then the outer query is executed. So that is one of the nested subqueries which we'll learn in the next question. Which brings us to the 13th question in our list, which is to explain the difference between nested and correlated subquery. In nested subquery, the inner query is nested within another query. The result of this inner query is independent of the outer query. By that I mean to say that whatever the values that are used in inner query does not reference to any columns from the outer query. And so the inner query is executed first and only once whatever the output that we got from the inner query is used then for the outer query. Whereas in correlated subqueries, that is not the case. The inner and the outer queries are correlated to each other. That means the inner query references the columns from the outer query, or the inner query is dependent on the values of the current row of the outer query. You can think of it as a loop inside a loop. So the outer loop is looping for each row in the table, and the inner loop is using those values from each row of the table for calculating some other things. And that is why the inner query is executed repeatedly for each row processed by the outer query. Now in order to understand this, let us take a simple example. Consider a scenario where we want to retrieve the student IDs of all the students in the class who got their score higher than the average score of the class. For this, as we have already seen in the previous question, we can write the following SQL query. Now in this query we have used a subquery as well, which is in the brackets down below, which is used to calculate the average score of the class. And this subquery will be executed first, and whatever the output of this subquery is will be used to compare the score of all the students if they are greater or not, and then the final output will be shown. This is the example of a nested subquery. In this, the subquery is executed only once and it is independent of the outer query. Now consider next scenario where we want to find the number of orders placed by each of the customers on any e-commerce platforms. For that, consider two tables. One is the customers table, which contains the information about my customers along with the customer IDs that they have. The another table is the order tables, which contains the information about all the customers that have bought on that particular e-commerce platform along with their customer IDs. Now if you see in the whole query, the subquery that is used counts all the values from the table orders only where the orders customer ID matches with the customer ID. Now if you see, this is a case for correlated subqueries. That means the inner query is correlated to the outer query. If you see the inner query where condition, the customer ID is matched with the table which is from the outer query. That means that this query will be executed repeatedly for each row which contains the customer IDs from the customers, and for each customer IDs the condition will be matched and the number of orders will be counted, and that is why it is called the correlated subqueries. Okay, let's come to the 14th question in our list, which is what is pattern matching in SQL? So pattern matching in SQL refers to the possibility of searching for specific patterns or substrings within the textual data in the database. There are two wildcard characters that are used for pattern matching. The first one being percentage character, which matches 0 or more characters. Let us consider this example where I need to find the emails which end with the .com value. Now I am not sure how many characters will be there before this .com word, and that is why I can use this percentage character here, which will match any number of characters that are there before this .com word. The second wildcard character is the underscore character, which matches only single character in the sentence. That means the number of underscore character that we have used should be equal to the number of characters that we want to exactly match. Consider this simple case here. I have a table dictionary and I want to find all the words in the dictionary which have A in their second position. Because here in this case I know that there should be only one letter before the letter A, and that is why I've used one underscore character. And after that I've used the percentage symbol, which means there could be any number of characters after the letter A. Great. Let us look at the second last question of our list, which is to explain the ACID properties in SQL. So ACID is an acronym which stands for atomicity, consistency, isolation and durability. Now these are the essential properties that ensure the reliability and integrity of the database transactions. Now commands like creating a table, updating the table or deleting rows from the table are all examples of database transactions. Let us see what these properties actually mean. When we say atomicity, then the entire transaction in SQL should take place at once or it should not happen at all. Now in other words, I can say that whatever transactions are happening in SQL, they should not be remain incomplete. Either they will happen or they will not happen at all. The second property is consistency, which says that the database must be consistent before and after the transaction. Now it is pretty straightforward to understand. The next one is the isolation property, which says that the multiple transactions should occur independently without any interference. Consider the case where our databases are shared with multiple users. Now multiple users are doing multiple transactions and that could occur at a single point of time. Now in that scenario, it is necessary that these transactions are occurring independent of each other. Then we have durability, which is the property which says that the changes of the successful transaction should occur even if the system fails. And that ensures that whenever an unexpected system failure occurs, the transactions that we are doing are durable enough that they will occur if the transaction is successful. So let us look at the last question in our list, which is what is the difference between SQL and NoSQL databases? Now this is pretty easier to answer. So the SQL and NoSQL are both in broad terms are a database management systems, basically a part of database management systems. In SQL databases, they typically use relational data models. That means the data is organized into tabular form. And that also means that the structure of the data must be defined before storing it. For example, when I need to create a table, I need to define the column names before entering the data into it. And that means that the structure of the data must be decided before entering the data in these SQL databases. Whereas in NoSQL databases, the data models used are not in the form of tables, but they are stored in the form of documents, key value pairs, wide column, and graph-based data models. And so the structure of the data is not defined, which allows for more dynamic data storage while storing the data. One more thing to remember for your interview round is, whenever we say NoSQL, by that we can mean either not only SQL or non-SQL. Both the terms are equally correct. So those were all the questions that I want you to prepare thoroughly before the interview. However, these questions are not enough, since along with the theoretical knowledge, you also need to know how you can write these queries in SQL. To prepare for that part, you can watch my complete tutorial on SQL queries by clicking this video. Thank you for watching and see you on the other side.